guys, in today's video I'll be taking you through manufacturing systems design, advanced PLC. So we'll be using two simulation softwares called CODESYS and CIROS. CODESYS is for inserting our code or variable using either ladder logic or structured text, but not limited to these coding languages. But for our lab, we're only going to be using these two languages, and for this particular lab or for this video, I'll be taking you through ladder logic, and the next one will be structured text. Okay, so since we're going to be working on PLC or advanced PLC, what is PLC? What does PLC stand for? It stands for Programmable Logic Controller. So these are industrial computers that are used to automate manufacturing processes, production lines, stations, machinery. So they control, or rather automate, even MPS stations, so which we're going to be programming today. So we're going to be programming a distributing modular programmable station on CIROS. So we'll be working on a virtual station simulating, or rather imitating, real industry. So everything that we'll be doing today, students can actually take or acquire skills from this exercise which they can use in industry, because this is exactly what they can expect in industry. These are actual real stations that we even have in our labs. All right. So what are MPS stations? They are modular programmable stations, meaning that they can be combined to form one process. So they'll be using one PLC in where a code will be inserted or a program will be inserted, and they'll be using basically there will not be standalone machines or standalone stations. So, okay, for this particular exercise, we are going to be using the distributing MPS station as an example. So it will be a standalone station that is not combined or joined onto another station. So we'll be using ladder logic as our coding language. Right, so let us get into it. This is your lab guide that you can use to follow detailed instructions on how to configure both of these softwares and how to program a virtual MPS station. Alright, so let us start with opening CODESYS. Please make sure that you chose the correct version, which is 3.5, because if you choose version 2, then your drivers are outdated and you might have a problem when it's time for you to simulate. Simulation, is very important, because that's the actual purpose of this exercise, is to simulate. So if your robot or your station doesn't work, basically it's not simulating, then you're going to lose a lot of marks, about 50%. So it's very important, because if it's not simulating, then what's the purpose of this exercise or this lab? Okay, so you click new project, standard project. Never ever choose this standard project with application composer. It's very important how you configure, because once you are done inserting your code and following other correct configuration steps, but missing this one, you're going to have a problem. How do you save your file? You use your student number, surname, initials, surname. And then if you do have ThoughtSpace on your PC, then save on ThoughtSpace, because in case there's any PC malfunctions, you are able to retrieve your work even after restarting your computer. Okay. All right, while it's loading, I'll just show you a picture of how our station looks like. Right, this is our station, a distributing MPS station. Our station is made up of a cylinder, a magazine. This is a cylinder, this is our magazine. This is where we're going to be inserting our parts. These are our parts or components. We're going to be inserting them in this magazine, and then the cylinder, you are required to actually program the station to ensure that these parts are released onto the conveyor belt. Then the cylinder needs to extend or advance, right? So it's made up of actuators, which are our push buttons, our emergency stop buttons, our stop buttons. Those are our actuators. And then also our inputs. So our push buttons are our inputs as well. And we also have sensors as our inputs. So these blue circles, these are our sensors. So we have these tiny blue circles. These are our sensors. And this is our conveyor belt. So we'll be programming this robot to release these parts from the magazine by extending the cylinder. And then once they get to this conveyor belt, sensor I1 at point B needs to detect that there's a part that has been placed onto the conveyor belt. And then it should send signals to the conveyor belt to start running or moving forward. So our outputs are represented as cues. It's very important how you name your outputs, your inputs, your actuators, because you're going to be using a specific coding language to ensure that your program is correct. So if you're going to put your Q as a small letter Q, your I as a small letter I, or you choose to be creative and put K because your name starts with a K, then your variables are going to be incorrect and your code or program is going to be incorrect. You will not be able to simulate. Okay? So please, you're not using any other variables but the ones that you see here. Okay, so let us move to the second part of the station, where we actually see our cylinder. So this is how our cylinder looks like up close. We have, like I said, this small circle, blue circles are our sensors. So we have I4, our sensors are represented as I's. Those are our variables. So capital letter I. Our outputs, capital letter Q, right? Okay, so this is our I4 cylinder retract, meaning this is our sensor that detects the cylinder when it's at its retracted end position. And then our I5 is our sensor number 5, which detects when our cylinder is at its fully advanced position, or when our sensor has extended. Okay, so when our sensor extends, releasing parts onto the conveyor belt, then our I4 here is activated. It senses the position, which is the fully advanced position of the cylinder. All right, so our Q0 is the conveyor belt moving forward. Our Q4, it is the cylinder getting extended, releasing parts onto the conveyor belt. So it's very important for you guys to understand your variables so that you know when you are building your ladder logic diagram or when you are writing your code, what is what am I trying to achieve? Okay, so, and then these are our variables. Also, it's very important for you guys to actually learn your variables. I'm not going to go through what is a Boolean, what is this, what is that, because for this exercise, you'll just have to copy and paste the variables as they are. You don't change anything. Okay. So we gonna open our CODESYS. So we named or saved our project using student number, initial, surname, right? And then, very important, choose the correct device. This is the device that you're supposed to choose. It is stated even on your lab guide. CODESYS Control WinVin3, V3, version 3. And then for your programming language, you're either going to choose ladder logic diagram or structured text, depending on what is required from you. For the purpose of this exercise, I'm only requiring you to select ladder logic diagram since we're going to be using ladder logic. Then you click OK. So most of these options are there by default because we usually come to the lab, we use these PCs, and when the next person comes, everything is already set up by default. You need to double check if it's correct or not. So if your device is incorrect, then just forget that is a 0. You're not going to achieve what you want. Okay, so the next step is we're going to click on application, right click, and then you're going to add object. Then we are adding symbol configuration. So if this is not there by default, if this is disabled, then you need to enable your support OPC UA features as well as your optimized layout. Usually this is already enabled by default, and the only thing you have to do is to click add. Okay, so we have our system configuration. What is the purpose of having this system configuration? Is so that we are able to enable and build, to enable our symbols and then build. Okay, so I'm going to show you what our symbols are, and then we will be able to build, right? Okay, from here, we're going to come back and build once we have inserted our code, but it's up to you. You can start building now, but you're only going to have two. Okay, let us build. I'm going to show you. You're only going to have two symbols, and then there's a third one, which is your code that has to appear here. You don't have it yet because you haven't inserted your variables. Once you insert your variables, then this third symbol will appear, and then you will have to enable these checkboxes. Okay, so for now, usually I don't like to build without inserting my code, because in most cases, once you start building, then when you've inserted your code, you forget that we need to go back and build. So either way, you check which one works best for you. So from here, I go to settings. Then this support already is enabled. You need to now enable direct IO access. Go to online, click simulation, because that's the purpose of this exercise. Right, we are not done with our configuration because we still need these three checkboxes enabled, or our symbols enabled. So you're going to double click here. Remember, this is where you are inserting your code. Double click here, and then there's your sheet for inserting your variables. var or var stands for variables, and var and variables, meaning that that's the ending. You are done. You are no longer going to insert your code. You can't have your code after this. Your code must always be between var and end var. So it should be here. Let us go to our lab guide. We're going to copy and paste our code as it is. Right, there's our code. What's the next step? To enable and build. Now we have our code as our third variable. We have to enable all three variables, then click build. Okay, we're done configuring our CODESYS. What do we have to do now? We must, since this is ladder logic, we need to build or develop a ladder logic diagram. How do we develop a ladder logic diagram? We have this sheet for building a ladder logic diagram. If you still want to check your code, you can click here and then drop this at the bottom. Then you can see all your variables. Cool. So if you want, you are building your ladder logic diagrams and you want more space, you do the same thing. Okay. All right, so our ladder logic diagram, we have what you call contacts as well as coils. What are contacts? Our contacts are our inputs. So those are our push buttons, those are our stop buttons, those are our sensors, and then our outputs are our coils. So this is a contact. I'm going to insert it. This is a contact. It's like an H without a horizontal line to make it an actual H. And then this is our coil, something that looks like a bracket. Right. So this is our output. Okay, whether you want to run your conveyor belt or you want your cylinder to be extended, these outputs you will insert here. All right, so our inputs, let's say I'm now giving you a scenario. So I'm giving you a scenario to extend your cylinder so that so that you are able to take parts that are stacked up in your magazine or in the magazine of your MPS distributing station. So let us go back to the picture. The aim is for you to stack in components or parts in this magazine so that this cylinder can advance, release these parts onto the conveyor belt. That's it. We don't want the conveyor belt to start moving or whatever. We are only starting with the simplest process. Just removing these components or parts out of the magazine. Right, how are we going to remove these? How are we going to remove these? Okay, so obviously we're going to need I5 because we use I5, right? I5 detects when the cylinder is advanced. And then the cylinder getting extended itself as an output, it is our Q4. So clearly we're going to need Q4, right? Clearly we're going to need Q4, clearly we're going to need I5. But what will be our actuator? What will be our process initiator? How will we start this process? Will these parts or components placed in the magazine get released automatically through the cylinder? Or is there someone, an operator, who's going to click a switch or a push button to start our process, since push buttons are also our actuators or inputs? So for this distributing station, our actuator will be our push button. So our initiator, our operator, will be the one to go and manually click the push button to start the process. After clicking the push button, then the cylinder will get advanced, releasing these components onto the conveyor belt. So what is our push button? We don't see it from this picture. It should be on the side of the MPS station, but you'll see it on CIROS. So let us just check it so that we are aware of what variable is our push button. So our push button is PO, push button for starting the process of extending the cylinder to release parts onto the conveyor belt. So we're going to need PO to start our process to achieve Q4, which is extending the cylinder. And then we're always going to have our push button stop or our stop push button, because you can't be a manufacturing company running a big company purchasing commercial machines only for you to run a process perfectly without having any errors or having any bottlenecks, any machine breakdowns. So all of those things, you need to really consider all of those things. So all MPS stations, they are supposed to have a stop push button or an emergency stop button. In case of any error, bottleneck, or defects, then operators are able to pause or stop the machine or robot from working in order to resolve the error. Also, it is for safety practice, okay, because then you are running at a high risk if you're not going to have a stop button, because robots or machines, we all know that they are not safe. Hence, you always have to follow a certain procedure, adhere to certain rules and regulations of operating those machines, and hence operators are trained. They go through intense training for them to qualify to operate certain machines or stations. Okay, so already we know we're going to need these two, right, for our ladder logic diagram, because our ladder logic diagram, we're basically imitating what we already have in our program or code. But we're not going to have everything because it depends what we are trying to achieve. In this case, we are only taking one part of the station, just releasing the parts onto the conveyor belt. But we will move gradually and then get the station more complex. But let's start with the most basic one. All right. So this is the most basic one. This is what we are trying to achieve, which is our Q4. This is what we are trying to achieve. Okay, so we have this, we have what we are trying to achieve, and we're going to need this. our input, which is I5, the cylinder getting advanced. This is our other input. I'll just make it blue. Right. Okay, let's go to CODESYS now. Remember, our contact is what? These are our inputs. What is the first input we're going to use? It is the first input that we use to initiate the process or to start the process. In this case, we're going to need a push button to start the process. What is our push button? Start push button, it's PO. So please, everything must be in order. Everything must be exactly the same. We don't say now that we're building our ladder logic diagram, we're going to put our P in a small letter, as a small letter P. So it must be exactly the same, okay? And then our output, what we're trying to achieve is what? Is Q4, which is getting the... Okay, we are trying to achieve Q4, which is getting the cylinder extended or getting the cylinder advanced. Here is our Q4. So we correct, right? And then once the part is placed onto the conveyor belt, which sensor do we have that senses whether the part is here? It's I1. But because we are not dealing with the conveyor as yet, we then say we can't use I1 because we don't want the conveyor belt to move, right? We can't use I2 because we don't want the conveyor belt to stop. So we're going to use I5 because it supports the outcome of extending the cylinder. It detects the position of the cylinder when it's fully advanced. Why is it detecting that? So that it can send a signal to a cylinder to retract once it reaches its fully advanced or fully extended position. So we don't want to release a part onto the conveyor belt and then our cylinder is still advanced, because we are running a manufacturing company, and immediately after releasing your part, then the cylinder needs to retract back to its retracted position or initial position or resting position until there's another part or component in the magazine, then it can release. So it's up to you, or based on the statement that you're given, if you're going to use a timer to release or to retract. If it's going to delay by 5 seconds to retract, or it's going to retract immediately. But for this exercise, we are not putting a timer yet. There is no delay. It needs to retract immediately. So we know we're going to need I5. Okay, our P1, we are starting our process. Our Q4 is our actual process, the cylinder getting extended. So we're going to create what is called a latch. There's notes on what a latch is. Why are we latching? But briefly, as you can see, this is Q4, right? This is our output input. So our input parallel to our output, that's a latch. In simple terms, a latch is like creating a loop, right? You want this process to keep running continuously without stopping, unless then there's a sensor or there's an actuator that will be used to stop that process from running. So for an instance, since we want our cylinder to extend, right? Usually when you click your push button and you release your hand, right? When you click a push button, for an instance, in basic pneumatics, in electropneumatics, when you click a push button and release your hand, the cylinder will extend and retract automatically after reaching its fully extended position. Sometimes it will not even fully extend, depending on how long you held onto the push button. So if you hold onto the push button for like 2 seconds and release your hand, probably your cylinder might slightly advance and then retract back automatically. And then when you click the push button, hold on to it for like a minute or 2 minutes, then your cylinder might advance to its fully extended position. Once you release your hand, then it retracts automatically. So For the purpose of this exercise, we want to achieve the second scenario, which is we want the acting cylinder to advance to its fully advanced position. So instead of having an operator holding onto the push button for each and every component that will be released onto the conveyor belt, we are then creating a loop or a latch to program this acting cylinder to fully advanced without this operator manually holding the push button until it's fully advanced. So we want the push button to continuously send signals. We want this push button to continually send a signal to extend our cylinder. Hence, it is input parallel to output, because we want it to continuously send a signal to its output to the cylinder to keep on getting extended until its fully advanced position. And even when it reaches its fully advanced position, it should latch. It should hold on to that position and not move. It should remain in that position until it is manually stopped or automatically stopped by a sensor or an actuator. Okay, so that's why we are latching. We want this to fully advance without getting distracted by anything. So we're going to add what? We're going to add our other contact, which will be our P1. What is our P1? Our P1 is our stop button. Our P1 is our stop button. As I said, you're always going to insert your stop button, and it will always be on this side because we are not using it to start our process or to run our process, but to stop it. So usually when I teach my students, I would say, once you create this loop, anything that comes after this, it is to oppose what we are trying to achieve. So what are we trying to achieve? We want our cylinder to extend. Anything that comes after, then it is there to retract our cylinder. Okay, I'll repeat. So usually I'd tell you guys that once you create this loop, this latch, anything that comes after is a different process as this one. What we are trying to achieve here, we want this cylinder to get advanced. But after this loop, then anything that comes after, it's opposing what we are trying to achieve. So this stop button, this stop button is for stopping the process. It is for stopping the cylinder from getting advanced, right? So anything that will retract our cylinder or stop our cylinder from getting advanced, we are putting it after our loop, which is our emergency stop as well as our sensor. Our sensor is I5. Why is it I5? We're going to go back because it is our I5 detects the position of our cylinder when it's fully advanced in order for it to send a signal to the cylinder to fully retract or move back to its original position, which is 0.020, its resting position. Okay, so we have everything that we need to program our robot to release these parts onto the conveyor belt. Okay, however, so when it comes to our actuators, when it comes to our inputs, our sensors, our push buttons, there is a normally closed push button and a normally open push button. There's a normally closed sensor and a normally open sensor. These are just states of our inputs and actuators, right? They are the original states of our sensors and push buttons. So our I5, it is normally open. It's a normally open sensor. One would ask and say, how can you tell that? How do you pick? Do you just pick and choose and say, I'll make I0 to be normally open, I'll make I4 to be normally closed? You don't pick and choose, right? From the picture, even when you are using CIROS, you'll be able to see that which sensor is normally closed or which sensor is normally open. I think my picture is not clear, but I'm not sure if it's here. Usually how you would detect is you're normally, a sensor that is off will be dark blue or navy blue, and a sensor that is on will be light blue or baby blue, right? To show that there's light, it is on. So that is just its original state, meaning that when you purchase the sensor, it is on. That is its original state. And then when you purchase another one, its original state, it is off. So when you start activating it, it will turn on. Okay, for an instance, this sensor here, right? This sensor here, okay, I don't want to confuse you because we are dealing with the cylinder for now. So, okay, our i5, even though it's not clear on the picture if it's light blue or dark blue, but our i5 is normally open, right? It is normally open, meaning that it is always off, right? This is always off until the cylinder is extended, then it turns on. It switches on. Why? Because now it is sending signals to the cylinder to retract to its original position. Okay, so that's how you would see that this sensor, its state, it is normally open or normally closed. When it's normally open, then it means it is always off. When it's normally closed, meaning that it is always on. It is always on, like this sensor here. Sensor I2 is always on until a part reaches this sensor, then it turns off. I'm not sure if I'm making sense, but okay. Let us work on I5 for now. So I5, it is normally open. It's normally open. Okay, guys, so I want to show you normally open and normally closed. Yes, I want to show you normally open and normally closed sensor. So a normally open and a normally closed sensor. This is a normally open. This is a normally closed. So this being a normally closed, it means it allows current to pass through. Already in its original state, current can pass through, right? For an instance, our P0. Our P0 is our push button. It is normally open until the operator clicks on this push button and then it closes, allowing current to pass through, right? And then our P1, which is our emergency stop button, it is normally closed. Hence, after clicking this push button, power flows. It goes to P1, it still flows until it reaches I5. Then power doesn't flow because this is normally open. Its original state is a normally open sensor. So what do we have to do then to allow power to flow? So to allow power to flow, we're going to negate this sensor, right? Negation is basically forcing or changing the state, the current state of an input in order to allow current to flow and to achieve your outcome or output. So how do we do that? Right click and then you're going to click negation. Then this diagonal line, it shows that you have changed the state of this sensor to be anomaly, to be closed to allow current to flow. Okay, so this is it. From here, we're gonna go to our CIROS. So CIROS, you click File, New, MPS, and then you're gonna save your work using your student number again, initials, surname, and then please create a folder with your details so that you, whenever you're supposed to submit, you know exactly where you saved your work. Okay, so this is our CIROS. Then from here, we go to Festo MPS, And then because we want to add a distributing MPS station with a conveyor belt, we're going to choose this one. Then you click add. If you were programming a sorting station, you were going to choose a sorting station. If it was a separating, then you're going to choose a separating. But for this exercise, we are choosing a distributing. Okay, from here, okay, so this is our station. We've added our station. From adding our station, we can close this. And then you can use these to navigate through CIROS, zoom in and out through the mouse roll, rotate. Oh. Okay, rotate. This is our cylinder. This is our I5. I5 cylinder, magazine, our parts. We're going to stack them in here. Then this cylinder, when it's advanced, it will supply these parts onto the conveyor belt. This is our I1, which will detect the part and start running the conveyor belt. This is our I2, which will stop the conveyor belt when the part is detected here. Because if we don't have I2 activated, then our parts are going to fall off. And we do not want that. Okay. Let me rotate again because I'm looking for our push button. Okay, this is our control panel. We have our push button and our stop button. Our PO, our P1. Okay guys, so from here we're going to click Modeling, Model Explorer. From Model Explorer, we're going to click Objects. From Objects, you're going to click your conveyor station and then choose PLC Distributing, right click, select Properties and click Control, change this to OPC Client. Click the drop down on OPC Client, select Items and then Connect. From here, you're going to select PLC, Virtual PLC, then you're going to click Apply, click the drop down and select Bits. Then Apply. So we can close this. We can close this, extend this to check our bits. And then, all right, so we have our items. So our bits, this is basically us imitating what we have on CODESYS, right, into CIROS. So CIROS, it's language, so it's language for inputs and outputs. For inputs, it's EPs, right? We are using bits. So we're going to be using EPs as our inputs. That's the language that CIROS is taking or that CIROS takes. Our EPs represent our inputs. Our APs represent our outputs. So EP, inputs, AP, outputs. What are our inputs? Panel inputs, which is our push buttons. Distributing inputs, which are the actual variables or programs of running or programming a distributing station. They are still our EPs, and then our outputs are APs. So how do you know what to select here? Go to CODESYS, you observe your variables. So these are your panel inputs, your POs, right? Usually I say, observe the first number that comes after your X, right? So it's X 0.0. When you go to CODESYS, you now want to assign your EPs accordingly or your panel inputs accordingly. So these are your panel inputs because we have panel inputs from I0 up to I7. Even our distributing inputs from I0 to I7, Even our panel inputs, we're going to insert them from 0 to 0 up to 0, 7. So since our panel inputs, the first number after our X is 0, then 0.0, we then going to click items under our bits which start with 0 point. So our inputs, number one, our panels are inputs, meaning we're going to choose EP. And since these are our panel inputs and how they are presented on CODESYS, they are 0.01 up to 0 point, right? So then we're going to select EP0, bit 0.0 up to bit 0.07. Right, okay, so take this, drag and drop under your panel inputs. We're done. So go back to CODESYS, observe your distributing inputs. What is the number that comes after X? If it's 2, it means you're going to choose EP2. If it's 1, it means you're going to choose EP1. In this case, it's 1. So we'll choose EP1. Where's our EP1? It starts from here. So you click control, then you select all your EP1s up to 0.7. You drag and drop. Since these are our distributing inputs, these are our eyes. These are our sensors. So you're going to drag and drop. 0, 1, 2, 3, 4, 5. 6 is missing here. So if you do come across this error, you don't have to select everything. You just come and correct this. So I'm going to select, I didn't select 6 and 7. I'll select 6 and 7 and then place it accordingly. Then everything is fine. So it's always good to double check and observe if your inputs and outputs are correct. Do you have everything from 0 to 0 up to 0.7, or is there any number that is missing? So okay, what else are we supposed, since we are imitating our code on CODESYS, we need to then insert everything that is here. So we haven't inserted our outputs. Then observe what is the first number that comes after X. It is 1. Meaning that since our outputs are ABs, instead of choosing AB0, bit 0.0 up to 0.7, we're going to choose AB1. Why? Because we are imitating what we have on CODESYS. If this was 2, we were going to choose AB2. If this was 3, we were going to choose AB3. Okay, so AB1, it starts here. AB1, bit 0.0 until bit 0.7. Where is it going? Under in outputs. Where are our outputs? Here is our cues. So after inserting your code or your program accordingly, then you click apply. Apply, sharp. Right, then we can close. We are done configuring our CODESYS. Okay, every time before I start my program, I like to click this button. It's for restart before I select simulate or play. This is what I'm going to do. Then I stack in my items or my products in here. Doesn't matter which one I would like to choose. If you want red, you choose red. If you want this one, then you insert that one. So we're only going to click our start button once we have simulated under CODESYS, because we are using this, remember, to program our robot this side. So we then go to login, select login with download, and then click play. Something like this should pop up, which is your Festo Easy port. Then you should have your CODESYS installed, version 3, not 2. It should say connected to localhost, one client, connected. These two, they are okay as they are. So if this is not connected to localhost, it's written disconnected, something is wrong with your configuration. You need to check for the errors. You probably made an error. Okay. Usually if your CODESYS is written version 2, you come here, you go to settings, you change that to V3. You never close, you just minimize. Right, once you have this, this is a green light that everything looks good, you'll be able to simulate. Never forget to play. If you don't play, then you won't be able to simulate. Then we go to CIROS. Like I said, you restart, you click play, you insert your parts, right? And then we are ready to then click our push button. There's our cylinder advanced, releasing our part onto the conveyor belt. There's our sensor I2, I1. This is I0, I1, I2, I5, I4. Okay, let's restart. Put it again. Okay, play first. Oh, okay. Restart. Play. Okay, I don't know what's happening. Okay, our cylinder is advancing even though there's no part in there. Did I restart? Did I? Okay, let me go to CODESYS, log out, log in again, play. No, why is it doing this? Okay, I wanted to repeat this one more time, but it seems like we're gonna move on to the second one. Okay, I've stopped, it retracted. Yes, it should. Okay, I had forgotten to stop. So you reset and you click stop, you start over your process. Okay, now I can click play. See my sensor. I wanted you guys to pay attention to the sensor. Let me stop. Okay, let me reset again. Try reset and then start. Okay, yes. Look at the sensor, it is off. It's off, meaning that it stayed. What is it? It stayed. If it's off, it is normally open. So this is our eye. It's off, this one is on. So yes. Alright, let me then show you the difference. You see this is dark blue, this is light or powder blue. The normal state of I2 is normally, it's always on, right? It's always on, meaning it's normally closed. This one, it is always off, meaning, this is always, sorry guys, this is always on, meaning it's normally closed. Yes, this is normally closed. This is always off, meaning it's normally open. So this I1, it's normally open. Therefore, it will function as our push button since it's also normally open, but once you click the push button, then current flows. You're closing it, you're changing its state, current flows through. Same with this sensor, our I1, it is normally open. So when you're using it as your actuator to start your process, of running the conveyor belt, what makes it to be on is when it senses a part placed onto the conveyor belt. Then the state of this sensor changes. It becomes closed. Please pay attention to that. Now that it's sensing this part, it's on. Its state has changed. So we don't negate I1, because once there's a part being tested, its state changes. Okay. So we are done, guys, programming our robot to release the cylinder onto the conveyor belt. So now let's add a timer that will retract, that will cause a delay. Okay, before we add a timer that will cause a delay, let us program our robot to move the conveyor forward, or a station to move the conveyor forward. So you stop, you log out, and then what do we use now for our conveyor to run? Our outcome is Q0, right? Because it's the conveyor moving forward. What do we use? What is the initiator of the process? What makes the conveyor to move? It's our I1. When it detects a part, then the conveyor belt will move. So it will replace PO, which is our push button that side. And then this will replace Q4, which is our cylinder getting extended. Okay, so let us start there. This is now I1. This is now Q0. This is now Q0. This remains the same. This must change. Why is it changing? We no longer need I5 because I5 was supporting the extension of the cylinder. Now we are trying to achieve this process, moving the conveyor forward, or the conveyor moving forward. So what will stop the conveyor from moving forward? Remember, I said anything that comes after this loop, it actually opposes the actual process that we are trying to achieve. So what opposes the conveyor? What stops the conveyor belt from moving? It is our I1. It is our I2. Where's our I2? Here. So go back to CODESYS. Then instead of having I5, we're going to have I2. Now I want you to pay attention. Is I2 supposed to be negated or not? Okay, let's go there. Are we supposed to negate I2? I2, its state is normally on. It is always on. Meaning when this part comes here, it's gonna turn off. Right? It is its initial state. So since it's always on, is it a normally closed or a normally open? It's a normally closed. Excuse me, it's a normally closed. So since it's a normally closed sensor, we don't need to negate. We don't have to negate. So I'm going to go back to CODESYS, because why do we negate? We are forcing the state to change, to become normally closed, so that current can flow. I'll go back to Google. Normally closed, current flows, but normally open, current can't flow. So we negate to close this so that current can flow. So we don't have to close this. You don't have to negate, because I2 already current can flow since it's normally closed. Right, so go back to build. Any changes to your code or your ladder logic diagram, you must always go to simple configuration and build. Right. Then we can now log in with download. Click play. Go to our CIROS. Let's reset. Let's click our stop button. Okay, it's showing something. Oh, I forgot to click play after. Yeah, so if you don't click play, your components will not go in. Okay, so now, actually guys, now this is not gonna get extended. We're gonna have to put this manually there, but okay, I made a mistake by changing this. Okay, let me log out, log in. So we don't delete our first network diagram because remember this is one process. What do I mean by that? I mean the cylinder at first extends, releasing parts onto the conveyor belt. So we already had this. The second one is now when the conveyor belt starts moving. So you're not supposed to delete that first ladder logic diagram. So we're going to insert the network and then redo. You are not supposed to delete. But I was trying to show you what we are replacing. So our I5, we negate, I've already explained why. So this is what we're supposed to have. The first phase is when the extension of the cylinder, releasing parts onto the conveyor. Second phase is now the conveyor belt moving. Go back to system, build. Okay, log in online with download, and then click play, and then go restart, play, insert, insert, releasing, and then the conveyor starts moving. Conveyor starts moving. Release, the conveyor starts moving. Okay, so the conveyor will not move for the second part because already this sensor has detected that there's a part here, so stop the conveyor from moving. Unless the operator comes, takes these parts, place them onto the, whether it's a pallet or box, into the box or wherever. But because there's already a part here that is sensed, then the conveyor will not move at all. But let us restart, and the conveyor should move. Starts moving, and then so we have achieved our process, right, of extending the cylinder and the conveyor belt moving. So go back to CODESYS. All right, we go back to CODESYS, log out. What if I want to insert a timer? I want to insert a timer to say I want my cylinder, my conveyor belt to start moving after 5 seconds. Then I'm going to insert another network below. And then this is how we insert our timer. You're always going to start with your input. And then after your input, you're going to select function blocks. And then we'll choose set reset function block, SR. Then you drag and drop here where there's a highlighted green diamond. You drop there. And then you click enter to validate your set reset functional block. Select here, click here, and then we drag and drop our timer. Drag and drop our timer. You enter to validate that this is correct. This is where we're going to insert our time. So this is the standard way of inserting your time. It doesn't change. It's capital letter T, and then it's 5 for 5 seconds, and then an S for seconds. Then these question marks, we're going to remove them because this is where your timer will count. From 5 seconds, it will be 5, 4, 3, 2, 1, and then execute the process. Then we're going to select here to insert our coil, right? So our output is what? Is a memory latch. So we have what you call a memory latch that will memorize this timer, okay? It will memorize this timer. We represent it as M0. And then here, what are we setting the timer for? We are saying we are creating an on delay. I have notes. There's notes on delay and off delay. Anything that has to do with theory, guys, please go through the lab guide. I don't want to spend most of my time in this video explaining theory, but only application. I'll just briefly explain certain things. So what do you use to start your process? So we are using I1. I1, right, is our sensor that moves the conveyor belt. So we are saying we want the conveyor belt to wait for 5 seconds before it starts moving. So this is an on delay timer. We are delaying the process from starting. So you're going to put our I1 there, and then for resetting, you will always have your stop button, and depending on your process, for an instance, this is the memory that we want to record for this particular process. So we have our P1 and our I2. Okay, now, because we are adding a timer, we'll have to negate our P1 and I2. Why are we negating our P1 and I2 when we include a timer? Because we do not want to create a latch that continuously resets the time, right? We don't want to create a latch that continuously keeps on resetting the on delay. So hence, we are changing this to say we do not want current to flow. Since these are normally closed, current is already flowing, we are blocking it from flowing. Okay, because we don't want it to reset. So because we are saying this is equals to memory latch 0, then wherever we want this memory to be executed, we're going to replace it with MO. So we change our I1 to M0 because we want our I1 to read this memory here. Go back to system configuration, build, and then log in with download. Error occurred during the code C message list. Okay, we have our MO. We have our I1, P1, I2. Why do we have, okay, let's see. Huh? Okay, that's crazy. What's wrong with our code? Oh, because we've changed our I to MO. Is that so? Okay, so every time there's a change, you're representing or you are inserting a new variable, you might come across such errors and you have to keep on building. So if you don't build and you continue running your code or your program, then errors occur during code generation. See message below. No ways. Why do I have errors now? Okay, let me pause. Okay guys, I figured out the error. So it's our time. Our timer, we're supposed to put hash. So it's T hash, our sec 5 and S for seconds. Then we build. Log in with download. After logging in with download, now that's good. Okay, now that's good. Where do we go? We go to CIROS. This is our robot. We reset, play, insert your products, and then remember the conveyor belt should take 5 seconds. 5 seconds. Okay, I want you guys to observe both the timer okay, I want you guys to okay. All right, guys, I want you guys to see the timer when it counts, the 5 seconds. So let us play. Okay, go to CIROS, we play, come here. See, our timer is counting. Then our conveyor belt started moving. All right, we'll do it again. Okay, stop. Look out. Oh. Okay, guys, you insert your items. You click play. We're trying it one more time. It's counting again. It's counting, and then our conveyor starts moving. So now we're gonna insert a timer. So now we're gonna create a timer that will retract our cylinder after 5 seconds. Okay, so after 5 seconds, we want our cylinder to retract. So guys, we're gonna put M0 here. Why are we putting M0 here? Why are we reading this memory? Because it belongs to I1 and not I5. Okay, we are gonna use this memory because when the cylinder is at its advanced position, this is a condition, right? Then I1 will be activated because it's detecting a part. So coincidentally, it happens that these two processes are coexisting. So they are happening in one position at the same time. So we could use the memory for releasing or running the conveyor belt after 5 seconds to also retract after 5 seconds. So let's put that to test. All right, we go to system, we build. Come here, log in with download, okay. And then I want to observe the timer as well. So you're going to observe the timer. And observe the timer even here. And observe the timer even here. play, play, start. So after 5 seconds, our cylinder should retract. It retracted. So we were able to achieve both our goal of releasing the conveyor belt after 5 seconds as well as retracting our cylinder after 5 seconds. So we're gonna now include another scenario. Stop, log out. So what if I want my I5 to retract after 10 seconds? What if I want my I5 to retract after 5 seconds and I want my I1 to retract after 10 seconds? So let's put 10 here, because remember that scenario of changing this to M0 will not work if then now we are saying we want you to retract before the conveyor starts moving. So we're going to introduce a new network with a new memory. Oh, okay, no, I'm wrong. Remember, it's for a timer. So we're gonna, so it's SR1 underscore 1 because we are introducing a new timer. Turn underscore 1. Why? We are introducing memory 1. So we are saying we want this to run after 5 seconds while that one is running after 10 seconds. Let's not forget the hash. You saw the previous one. Any small mistake, nothing is going to run. So what are we putting here? We are putting our I5. Here we are putting our P1. And then we are putting our no, we are putting, what am I doing? We are putting I5 P0 here. Our coil is memory logic number 1. Then we're going to change this to M1. Go to build, 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 come here. So this memory should come to I5. I5 must retract, must sense when the part is there, and only retract the acting cylinder after 5 seconds. Then this must delay for 10 seconds. So it means it will wait for the extra 5 seconds to start moving the conveyor belt. So let us see if indeed, right, so let us observe both. Okay, so we're going to reset. Okay, let me log out first. Play. Right, and then let me click play. Play. Right, after clicking play, then let's see. So after 5 seconds, our cylinder should retract. When is our cylinder retracting? So yes, our conveyor moved after 10 seconds, but our cylinder is not retracting. Something must be wrong. Okay, let us observe if our code is correct. Okay. P0, P1. We didn't negate. Okay, let's see that. Our cylinder is retracting after 5 seconds. Our conveyor is advancing. So we've achieved what we wanted to achieve. Okay, let's log out. Right. So we had forgotten to negate our P1. Remember, its state is normally closed here, so we are changing it here. I5 is normally open. We negated to close it, so we're going to leave it open there so that it doesn't constantly reset. So we've achieved what we wanted to. These are different scenarios of programming your MPS station, distributing station, using on delay timers or off delay timers. So expect any of the scenarios that I've given you as your test using either ladder logic or structured text. Okay, let us check it one more time. Oh, I didn't click play. And then play this side. And then let's observe. What is it? Stop. Log out. Is everything fine? Yes, it is. Did we build? Yes, we did. What is that? Something. Don't know what it is, but something is off. Okay guys, you know what? My PC is acting up, so we're going to leave it here. We have achieved everything that we wanted to achieve. I just wanted to redo it. I don't know what's going on with my PC now, but you saw the first attempt, so you should be okay. So it's counting 5 seconds, the cylinder should retract. It's counting 10 seconds, the conveyor belt should run. Right guys, that's it for today. The next video, it will be based on structured text. Thank you.